Hello everyone, I am Premkumar Tambekar from IIT Delhi, pursuing civil engineering. I am presenting my project, Passive Sonar Detection and Classification System. Passive sonar listens. Passive sonar is a mature technology. Hydrophones listens to underwater environment over past 2 decades. The world has deployed a lot of hydrophones. Defense network, ocean observatories like NOAA, and others together produce terabytes of unlabeled acoustic data every day. But sensing has outpaced the interpretation. Distinguishing what is in those recordings is not doable by human analysts in most operational systems at large scale. Machine learning has in the field rapidly in the field since 2020 and promises to close that gap. Published literature reports 95 to 99% of classification accuracy on benchmark dataset. But when same systems are deployed on the new hydrophones, in new location, performance drops by 15 to 25 percentage points. Benchmark numbers do not reflect the operational reality. My project addresses this gap with the machine learning pipeline that classifies underwater acoustic sources into 4 categories using two-stage architecture. A binary detector first decides whether anything non-ambient is present, and then a multi-class classifier identifies what it is. The work began with a structured literature review. The UATR field has documented 3 issues. Most published work classifies vessels only. Evaluation is mostly done on single dataset, and the common evaluation protocols leak information by splitting at a segment level rather than the recording level. For data, I have selected 5 open datasets that together cover all 4 source types, and also looking for additional dataset to add to this. Curation requires a careful normalization because each dataset uses different hydrophones and with different gains and needs to apply per source normalization first and followed by global pass. Augmentation and annotation is also required for this data. Signal processing pipeline runs on selected features from STFT, LOFA, Dreaman, Mail spectrogram, MFCCs, GFCCs, fused as channels into network input. Literature has shown that using multiple feature channels concatenated gives better results. For both stages, I am comparing different models from the literature based on the performance. Models from the different families are going to be used and compared before final selection. And next step will be evaluation of the finalized model. Most important point of this work is integration. The underwater acoustic environment is not separate platforms, but for different stakeholders. It is a one shared environment rather than each community building its own narrow monitoring stack. For maritime security, stakeholders like Indian Navy, Coast Guard, and TRO can use this for the purpose of vessel detection in IOR shipping lanes, identification of low signature emitters, and monitoring of submarine cable corridors. In context of blue economy, this can be applied for illegal fishing detection, port approach traffic characterization, and acoustic baselines for offshore infrastructure by stakeholders like Ministry of Ports and Shipping, Fisheries Survey. For marine environment and ecology, the Ministry of Environment, the Wildlife Institute, the Zoological Survey can use these techniques to get cetaceans activity maps to inform protected area designation and quantify anthropogenic noise budget. For disaster risk reduction, Indian National Center for Ocean Information Service, National Disaster Management Authority, IMD, can use these techniques to get acoustic footprint from submarine seismicity, cyclones, and tsunami precursors. This project also contributes to research and indigenous capability building. Further research can be done using IOS-specific dataset and building the physics-informed modeling and simulation layer on top of this. More critically, all 4 classified outputs feed directly into the evidence-based India needs for spatial decision across its EEZ. This pipeline produces all 4 data layers from the one sensor tree. The expected outcomes are reproducible 4-class UATR baseline accompanied by full reproducibility artifacts such as splits, checkpoints, and code with consistent cross dataset performance. For currently, I am on dataset curation, and then I will be training model and evaluating them. In long term, This 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 work is to ground recognition engine in real ocean propagation physics. Connecting the engine to acoustic propagation model would let us characterize detection performance under realistic operational condition, which is the answer maritime operators actually need answered. Thank you for your time.